Hi, Dragons. Thank you for joining me this evening to go over comparing and ordering rational numbers. This has been a topic that we've had a lot of challenges with, so I was going to reteach you some strategies that can help you compare and order the rational numbers. First, you have to know what inequality symbols are. Inequality symbols include the greater than symbol, the less than symbol, they also include things that we may not use on this worksheet, but it includes the greater than or equal to, or the less than and equal to. Also for this worksheet, you're going to need the equal symbol. It says, place the appropriate inequality symbol between the following pairs of integers. Well, in fact, there's a typo on their worksheet here because these aren't integers. These are rational numbers because they include fractions, decimals, and percents. We talked about that in class. I think I'm going to need some extra paper here to work out some of these problems for you. So take a moment and get yourself some paper as well. Two ways we can handle comparisons. Actually, more than two ways. I'm going to brainstorm some ways. One, you can use benchmark fractions. You could ask yourself such things as, is it closer to 0? Is it closer to 1/2? Is it closer to 1 whole? Or you can do conversions. You could take a fraction and change it to a decimal. You could take a decimal and change it to a fraction. And you could take percents and change them to either fractions or decimals. That's one way you could try to do these. This is another strategy you could use to do these. You also can get common denominators as a way to compare. So just a couple strategies of how we can approach these. Let's begin with letter A. 2/7 compared to 3/10. 2/7 is relatively close to 0. 3/10 isn't that big. A little bit closer to half than I feel this one is. This would have to be 3.5 over 7 to be half. So you could use benchmark fractions, which would lead me to believe that this one is less than this one. But I want to prove it to you too. Now I could change this one to a decimal. If you're strong in division, this is a possibility. You could do 2 divided by 7. 2 divided by 7. You're going to add a decimal here. 7 can't go into 2. 7 can go into 20. 2 times 7 is 14. You're going to subtract. You get a 6. You're going to add a 0. You're going to bring down. 7 goes into 60. Looks like 8 times. 8 times 7 is 56. You're going to subtract. You get a 4. You get a 0. You bring down. 7 goes into 40. 5 times. 5 times 7 is 35. Subtract, get a 0, bring down. 7 goes into 50. Let's see, 6, 7 times. 7 times 7 is 49. Subtract. See, this is going on and on and on, and I'm not even sure if it'll stop. And I'm going to double check because I don't have this one memorized. Will it stop? Not even sure it'll stop because that's a pretty long answer. I have more than enough evidence here to show that this is less than this, which was my prediction. The other way you could do this, because maybe you're not strong on division and that's making you uncomfortable, that's okay. You can change this guy to a fraction. He is 3 over 10 because he lives in the tenths place. Maybe you can compare 2 sevenths to 3 tenths. Maybe you feel comfortable with that. 7 parts are bigger parts. You have 2 bigger parts or 3 smaller parts. One way to compare it. Or, even better, get common denominators. I'm not going to put a ton of thought into which common denominator I want to get to. I want to keep it easy peasy. So I'm just going for 70. Because I can see that 10 and 7 can get me 70. This is when you do your swoopy swoops. Times 7, times 7. I got 21 over 70 over here. Times 10, times 10. I got 20 over 70 over here. 20 over 70 is less than 21 over 70. Now, it's easier to choose which way you want to stick with. You can make most of them work. The literature I have read suggests that you convert all fractions to decimals. That means you have to be a strong divider. Most people in 6th grade are strong at this, creating equivalent fractions. Let's look at the next one. Negative 5/12 compared to negative 42/100. Right off the bat, I don't think they're going to have any kind of convenient common denominator. 1/2 would be 6 over 12. So this one is close to 1/2, and this one's close to 1/2, which means they're really quite close to each other. So using benchmark fractions this time is not working out great for me. I feel like I do want to go with converting this to a decimal, because I know 42 over 100, 12 and 100 aren't going to have the easiest common denominator. So I'm going to do 5 divided by 12. They're both negative, so that's not doing me any good right now. 12 goes into 50 4 times. 4 times 12, 48. Subtract. Add a 0, bring down. 12 goes into 20 1 time. I think I already have enough evidence. I do, because this is 0.41 and this is 0.42. So if this is closer to 0.41 being negative, which one is bigger? Is this one closer to 0 or is this one closer to 0? This one is ever so slightly closer to 0. So this one is greater than. Let's just double check. 5 divided by 12. Yep, good. I stopped here because I knew I could. The 1 was smaller than the 2, which gave me enough evidence to figure out which inequality symbol to use. Now, this is one we did in class. I have 1/4 memorized. 1/4 is 0.25, aka 2500ths. 2/10 is less than 2500ths. That's like saying 20 cents and 25 cents. 20 cents is less than 25 cents. This one is a positive and a negative. Use that skill to your advantage. Don't do more work than you need to. A positive is always greater than a negative. Now we have 2 negatives. 8/10 and negative 8/10 and negative 7/8. We could try... I think I'm going to go with common denominators here. I know how to rewrite this one very quickly into a fraction. 8/10 is just 8 over 10. I want to change these into things over 80. See if you can figure out why I chose 80. Hopefully you see that relationship there. So 10 times 8 gets me 80, so 8 times 8 gets me 64. 8 times 10 gets me 80. 7 times 10 gets me 70. So is negative 70 over 80 greater than or less than negative 64 over 80? Negative 70 over 80 is less than negative 64 over 80. This one is further away from 0. It goes further to the left. Again, a negative and a positive. The negative is going to be less than the positive. So to recap that, here we used common denominators. Here I used division to convert from fraction to decimal. Here I used some prior knowledge, but I did technically convert from fraction to decimal. Here I used my knowledge of positive and negative numbers. Here I used common denominators after I did a little conversion. And here I used my knowledge of positives and negatives as well. All right, good job. Good job. Let's take a look at the next part. You got to draw a little number line. I like to use a straight edge when I create a number line. We're going to mark a number line, draw a number line, and mark and label points for these numbers. I always like to take a look at what I have to deal with. I've got 0, 3/4, negative 25th hundredth. These are pretty small numbers. My number line can be pretty spread out. So I'm going to put 0 in the middle. I got 1, 2, 3. Try to make them equidistant from each other. It does make life a little bit easier to read. Negative 2. And negative 3 would have been about here. Excellent. I'm going in with another color to put the points. So I drew a basic number line. 0 is here. 0. Check. 3/4. 3/4 is 3/4 of the way to 1. That would be here. 3/4. Check. Negative 25 hundredths. This is negative 25 hundredths because this is a quarter, half, 3/4, negative 1. Check. 1 3/4. This is 1 3/4. Check. Negative 2.5. This is about half, so that's negative 2.5. Check. All right, next one. Draw a number line and mark and label points for these numbers. Let's see, tiny, tiny. Goes all the way up to negative. It's higher on the negative side. Let's see, I might want to draw my hash marks a little bit closer this time than I did on the last time. So I'm going to go in with a basic number line. Take my straight edge. Draw a line. Lines go on forever in both directions. We've got 0, 1, 2, 3, 4 is sufficient. It doesn't go past 4. Negative 1, negative 2, negative 3, negative 4. Some of these are going to be easier than others. 26 hundredths is pretty close to 1/4. So if this is 1/4, it's going to be right about here. I know that because 1/4 is 25 hundredths. Negative 2/7 isn't one that I'm crazy comfortable with, but we did the fraction on that one earlier. It's 20 over 70, which is pretty close to 0, I feel. That's pretty tiny. If it would make you comfortable for the practice, I would absolutely be happy to change it into a decimal so that we can be consistent. So, taking a look at that, we did do that earlier. This time it's negative though, so it's going to be negative 28 hundredths, little about negative 28 hundredths. So that's going to be about here, because it's close to 25 hundredths. So check, check. Negative 3.1. Here's negative 3.1 is just a skosh past that. Negative 3.1. Check. 1 2/3. So that would be 1 1/3, 1 2/3. Check. -2 7/8. That is pretty close to 3 without reaching 3. Check. So I hope these notes and directions will help you complete the homework side independently. We'll go over the answer key on that in class. Thank you.